Hi everyone, my name is Aria, and I work alongside Whitroy as an electrical tutor. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3000, 2018. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for EWRB exam. What this audiobook does is take the key ideas from the standard and explain them in simple, spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real installations. So think of this as a learning companion, not a replacement for the actual standard. Alright, let's get started. Hello everyone. In this section we are moving into section 8, which is all about verification. Verification is the final check that confirms an electrical installation is safe, compliant, and ready to be energized. In this section we will walk through visual inspection, mandatory testing, earth fault loop impedance, RCD operation, and verification records. Everything is explained in simple spoken language to help you understand not just what needs to be done, but why these checks matter in real electrical work. Clause 8.1 General. This clause introduces Section 8 and explains that this part of the standard is about verification. Verification means checking an electrical installation to make sure it meets the basic safety principles required by Part 1 of this standard. The focus is on inspection and testing so the installation can be confirmed as safe and fit for use. Clause 8.1.1 Application. This clause explains that Section 8 sets the minimum requirements for inspection and testing. These checks are required to confirm that an electrical installation meets the fundamental safety principles of this standard. In simple terms, it tells us that verification is a key step to prove the installation is safe before it is used. Clause 8.1.2 General Requirements. This clause explains that before an electrical installation, or any part of it, is put into service after construction, alteration, or repair, it must be verified as far as is practical. Verification is done to make sure the installation is safe to energize and will operate in line with the requirements of this standard. It also explains that once the work is finished and before the installation is put into service, the installation must be inspected in line with Clause 8.1.3 and Clause 8.2 as far as is practical, and it must be tested in line with Clause 8.3. The clause also reminds us that safety precautions must be taken during inspection and testing to protect people, property, and electrical equipment. Where work involves an alteration or repair to an existing installation, verification is required to confirm that the work complies with this standard and does not reduce the safety of the existing installation. The notes explain that extra inspection and testing may be needed for certain types of installations, and that in New Zealand, special attention is required for wiring and fittings located near conductive thermal insulation, as covered by NZECP 55. Clause 8.1.3 Periodic Inspection and Testing. This clause explains that electrical installations must also undergo periodic inspection and testing, not just checks at completion. These ongoing checks are required to confirm that the installation remains safe over time. The clause states that this inspection and testing must be carried out in line with the requirements set by the regulatory authority, and also by the owner or occupier of the premises. The note explains that recommended arrangements for periodic testing are provided in ASNZS 3019. Clause 8.2 Visual Inspection. This clause explains that visual inspection is a required part of verification. A visual inspection must be carried out once work on an electrical installation has been completed. The purpose is to confirm that the completed work meets the requirements of this standard. The inspection is normally done before testing or together with testing, and where practical it should be completed before the relevant part of the installation is placed into service. The clause also explains that if a visual inspection of part of the installation is not practical at the completion of the work, for example because it is enclosed within the building structure, consideration should be given to inspecting that part during the course of the installation instead. Clause 8.2.1 General. This clause reinforces that visual inspection is a mandatory step after work is completed. The inspection is carried out to verify compliance with this standard and to make sure the installation is suitable to be put into service. It highlights that visual inspection forms a key part of the overall verification process and works together with testing. Clause 8.2.2 Checklist. This clause explains that during a visual inspection, certain matters must be checked where they apply, to confirm that the relevant requirements of this standard have been met. It begins with general matters, including checking that basic protection is in place to prevent direct contact with live parts, such as correct insulation and enclosures. It also includes checking fault protection, to ensure protection against indirect contact with exposed conductive parts, for example through automatic disconnection of supply, double insulation, or isolating transformers. The inspection must also confirm protection against hazardous parts, such as guarding or enclosure of hot surfaces, flammable materials, or parts that could cause physical injury. Protection against the spread of fire is checked, including the integrity of fire barriers. The general condition of electrical equipment is assessed to identify signs of damage that could affect safe operation, and to confirm that unused electrical equipment has been disconnected. The clause then moves to consumer mains. These checks include confirming that the current carrying capacity is adequate, that voltage drop is appropriate for the size of the conductors, and that underground installations have suitable enclosure, burial depth, and mechanical protection. Aerial installation conditions are checked, along with the correctness of wiring connections and protection against external influences. For switchboards, the inspection includes checking the location to ensure safe access and egress. Protective devices are reviewed to confirm correct selection and settings so they comply with overcurrent protection, arc fault protection, and discrimination requirements. Isolating devices such as main switches are checked, along with connecting devices like neutral bars, earth bars, and active links. The inspection confirms that wiring and switchgear are properly connected and fixed, that equipment is clearly identified and labeled, and that protection against external influences is provided. For wiring systems, the inspection checks that conductor sizes are suitable for current carrying capacity and voltage drop, that cable cores are correctly identified, and that there is adequate support in fixing. Connections and enclosures are checked, along with particular installation conditions such as underground, aerial, or safety services. The inspection also confirms segregation from other services and electrical installations, and protection against external influences such as enclosure. For electrical equipment, the inspection includes checking isolation and switching devices used to protect against injury from mechanical movement, such as motors. It also includes checking isolation and switching devices used for protection against thermal effects, such as motors, room heaters, and water heaters. Switching devices for particular equipment, such as socket outlets and water heaters, are reviewed. The inspection confirms that special installation conditions are met, including locations affected by water, explosive atmospheres, extra low voltage, or high voltage. Compliance with the required standard is confirmed, along with correct connection, support, and fixing. Protection against external influences, including ingress of moisture where required, is checked, and the suitability of equipment for the intended voltage, current, and frequency is confirmed. The clause then covers earthing. The inspection checks the main connection, the earth electrode, and earthing conductors for correct size and identification. Equipotential bonding conductors are checked for size and identification, along with connections, joints, and terminations. Protection against external influences is confirmed, and connections to earthing arrangements for other systems are reviewed. The inspection also considers whether the creation of an earth situation may require additional earthing of electrical equipment. Clause 8.3 Testing. This clause introduces testing as the next stage of verification following visual inspection. Testing is carried out to confirm that the electrical installation complies with the requirements of this standard and is suitable for its intended use. Clause 8.3.1 General. This clause explains that after completion of the work, or in association with the visual inspection, tests must be carried out on the electrical installation in accordance with Clause 8.3.3. The purpose of these tests is to verify compliance with this standard and confirm that the installation is fit for use. The clause also allows for additional tests to be carried out if they are necessary. Clause 8.3.2, Test Methods. This clause explains that ASNZS 3017 sets out common test methods that may be used to verify, by testing, that a low-voltage electrical installation complies with this standard. It also includes minimum safety standards for test instruments. Testing must be carried out in a way that ensures the safety of the operator and other people nearby, and that test equipment is not placed at risk. The clause notes that the test methods given are reference methods, and other methods may be used provided they give equally valid results. Clause 8.3.2.2, Recording of Results. This clause explains that it is recommended the results of tests are recorded and maintained, especially where the results provide values used for verification. Keeping records helps demonstrate compliance and supports future inspection and testing. Clause 8.3.3, Mandatory Tests. This clause explains that certain tests are mandatory and must be carried out on parts of electrical installations designed to operate at low voltage. These tests include continuity of the earthing system, insulation resistance, polarity, correct circuit connections, verification of impedance required for automatic disconnection of supply, and operation of RCDs. The clause includes an exception that verification of earth fault loop impedance may be omitted where automatic disconnection of supply is not the method used to provide fault protection. The notes explain that some tests require the supply to be available, and that additional tests for isolated supplies are detailed elsewhere in the standard. Clause 8.3.3.1, Low Voltage. This clause specifically applies the mandatory test to low-voltage installations and confirms the scope of testing required for these systems. Clause 8.3.3.2, Extra Low Voltage. This clause explains that testing must also be carried out on parts of electrical installations designed to operate at extra low voltage. The required tests include continuity of the earthing system for PELV circuits, insulation resistance, polarity, and correct circuit connections, all in accordance with the relevant clauses referenced. Clause 8.3.3.3, Test Failures. This clause explains that if any part of the electrical installation fails a test, that test and any earlier tests that may have been affected by the fault must be repeated after the fault has been corrected. This ensures that the installation is fully compliant after rectification. Clause 8.3.4, Sequence of Tests. This clause explains that testing must follow a defined sequence. The testing sequence is shown in the standard, and the intention is to ensure tests are carried out in a logical order so results are valid and safety is maintained. Clause 8.3.5, Continuity of the earthing system. This clause explains that testing is required to prove continuity of the earthing system. This includes the main earthing conductor, protective earthing conductors, combined protective earthing and neutral conductors, and bonding conductors. The purpose is to ensure the earthing system is installed so that protective devices will operate if a fault occurs between live parts, other than the neutral, and the mass of earth. An effective earthing system prevents exposed conductive parts from reaching dangerous voltages under fault conditions. Where a PEN submain is installed in accordance with the reference clause, testing must confirm that the earth terminal or bar of the subboard is connected through the PEN conductor to the earth terminal or bar of the main switchboard. Clause 8.3.5.1 General. This clause reinforces the purpose of earthing continuity testing and explains how it supports correct operation of protective devices and overall electrical safety. Clause 8.3.5.2 Results. This clause explains that the resistance of protective earthing conductors must be low enough to allow sufficient current to flow to operate overcurrent protective devices, and consistent with the length, cross-sectional area, and type of conductor material. It also states that the resistance of the main earthing conductor or any equipotential bonding conductor must not exceed 0.5 ohms, with notes explaining how resistance values relate to protective devices and circuit characteristics. Clause 8.3.6, Insulation resistance. This clause explains that insulation resistance testing is carried out to ensure insulation between live conductors and earth, or between live parts and earth, is adequate to maintain insulation integrity. The purpose is to prevent electric shock hazards, fire hazards from short circuits, and equipment damage. It also explains that insulation resistance testing between conductors is necessary for consumer mains and submains to reduce the risk of injury or property damage due to insulation breakdown. Clause 8.3.6.1 General. This clause explains the safety purpose of insulation resistance testing and why it is critical for preventing shock, fire, and damage. Clause 8.3.6.2 Method. This clause explains that insulation integrity is tested by applying a direct current test voltage, typically 500 volts for low-voltage circuits. It also explains exceptions where equipment may need to be disconnected or switched off before testing to avoid damage, or where a reduced test voltage may be used for particular circuits. Clause 8.3.6.3 Results. This clause explains that insulation resistance values must not be less than 1 megohm between conductors of consumer mains and submains, and between live and earth parts of an electrical installation. It also explains acceptable lower values for specific situations, such as sheathed heating elements, ASNZS with functional earth connections, or values permitted by the relevant equipment standard. Notes explain how insulation resistance varies with cable length, material temperature, and type. Clause 8.3.7 Polarity and correct circuit connections. This clause explains that polarity and correct connection testing is carried out to prevent unsafe conditions. These include transposition of active and neutral conductors, incorrect combinations of active, neutral, and earthing connections that could energize exposed conductive parts, incorrect operation of switches or protective devices, and short circuits between conductors. Clause 8.3.7.1 General. This clause explains the safety reasons for polarity and connection testing, including preventing installations from becoming energized in unsafe ways and ensuring correct operation of equipment and protective devices. Clause 8.3.7.2 Results. This clause explains that testing must show that all active, neutral, and protective earthing conductors are correctly connected to the corresponding terminals of electrical equipment. It confirms that there is no dangerous transposition of conductors, that switches and protective devices operate in the correct conductors, that phase sequence is consistent where required, that no protective earthing conductor is connected in parallel with the neutral conductor, that there are no short circuits between conductors, and that there are no unintended interconnections between different circuits. It also clarifies that any MEN or ESA connection is not regarded as a short circuit. Clause 8.3.9 Verification of earth fault loop impedance, spoken as EFLI. This clause explains the requirements for verifying earth fault loop impedance. The purpose of EFLI verification is to confirm that, if an earth fault occurs, the fault current will be high enough to cause the protective device to disconnect the supply within the required time. This helps prevent electric shock and fire risk by ensuring automatic disconnection of supply works as intended. Clause 8.3.9.1 Low voltage socket outlet circuits. This clause explains that EFLI testing must be carried out for certain low voltage socket outlet circuits. These are circuits where fault protection is provided by automatic disconnection of supply, where the circuit supplies one or more socket outlets, and where those socket outlets are not protected by an RCD with a rated residual current of 30 mA or less. The notes explain that the testing method verifies that the protective device will disconnect an earth fault current within the required time and touch voltage limits. They also explain that EFLI testing is not required for RCD-protected socket outlets because the operating time of the RCD provides additional protection. The notes further explain that EFLI testing is generally not required for circuits supplying equipment other than socket outlets, and that for other circuits the maximum trip time requirement must still be met, even if EFLI testing itself is not required. Clause 8.3.9.2 Methods. This clause introduces the methods used for verifying earth fault loop impedance. It explains that one of the specified methods must be used, depending on whether supply is available at the time of testing. Clause 8.3.9.2.1 General. This clause explains that the choice of test method depends on the availability of supply. The methods described in the following clauses provide acceptable ways to verify earth fault loop impedance. Clause 8.3.9.2.2 Supply available. This clause explains that where supply is available, the earth fault loop impedance for each branch of each final subcircuit is measured using an earth fault loop impedance tester. The test is carried out at the socket outlet that is furthest from the supply on each branch of the final subcircuit. The clause also states that the MEN connection must be left intact during this testing. Clause 8.3.9.2.3 No supply available. This clause explains the method used when supply is not available. In this case, the total resistance of the active and protective earthing conductors of the circuit is measured using an ohmmeter. Each active conductor and the protective earthing conductor are connected together at the origin of the circuit, usually at the protective device. The resistance of each active and protective earthing conductor pair is then measured at the furthest point of each branch of the circuit. The notes explain that when supply is available, earth fault loop impedance testing is preferred because it verifies the complete earth fault loop, including the integrity of the MEN connection and the supply neutral or PEN conductors. Where supply is not available, the resistance method establishes the contribution of the final subcircuit to the total earth fault loop impedance. Clause 8.3.9.3 Results. This clause explains that the values obtained from EFLI verification must satisfy the requirements of Clause 5.7.4. The requirement is considered satisfied if the measured earth fault loop impedance does not exceed the maximum value for the applicable protective device, or if the measured total resistance of the active and protective earthing conductors does not exceed the maximum value for the applicable circuit protection and required disconnection time. The notes explain how the reference values used for these limits were calculated and the assumptions used for conductor resistance and temperature. Clause 8.3.10 Operation of RCDs. This clause explains that to verify correct installation, tests must be carried out on all RCDs. The function of the RCD must be verified either by operating the integral test device or by using suitable test equipment. The clause also explains that after an RCD has operated to disconnect the designated circuit, isolation of all switched poles must be verified. This can be done by voltage tests or by continuity checks after removing supply. The notes explain that operating the integral test device confirms correct functioning of the RCD and the integrity of its tripping mechanism, but it does not check earthing continuity, earth electrodes, or other parts of the earthing system. The notes also explain that there is no requirement to test the operating time of RCDs, and that suitable tests may be carried out using a test plug with a resistor between the active and earth pins. Clause 8.4 Verification Records. This clause explains that the date of initial certification of an installation must be available on site. This can be provided by permanent, indelible marking on or at the main switchboard. The note explains that knowing the details of the original verification is necessary to allow future re-verification and to support the operation of an ongoing verification regime when required. That brings us to the end of Section 8 on verification. At this point, the installation has been inspected, tested, and confirmed as safe to use. These steps are critical because they prove the work has been done correctly and that protective measures will operate when needed. Always remember that verification is not just a paperwork step, it is a key safety responsibility for every electrician. For legal and technical detail, always refer back to the official ASNZS 3000 standard.